Okay, so in last session, we have seen the statistics, how different concepts of statistics are applied, what are different statistics concepts that we will be using in order to evaluate the model. And then we have also discussed on the metrics that needs to be focused based on the use case. So basically, we have discussed on MAE, MSE, RMSE, and R square. And when we have to focus on these metrics based on the different use case that we want to solve. Then we have also discussed on the range of these metrics, right? So let's say R square, if we'll consider, so for R square, excellent range is when the value of R square is greater than 0.9. Good range is between 0.6 to 0.9 and poor range is less than 0.6. So this is the acceptable range and this is the non-acceptable range for these parameters. And then we have also discussed on the condition when our model will be considered as overfitting or underfitting based on the train and test ranges. So we will come to this later on. So we will use this concept to basically build a detailed machine learning pipeline where we will consider these matrices and then we will evaluate whether our model is basically a good fit or underfitting or overfitting. And then if it is underfitting, then what exactly needs to be done? If it is overfitting, then what all steps we need to take care in order to make it a good fit. That we will see. Uh, uh, I mean, after classification, right? So, in today's session, I'll be discussing on the classification. So, finally, once we'll, finish off with the classification, then I'll take one example and build the complete machine learning pipeline and incorporate these concepts that we have learned in the last class. So today we will be discussing about the classification, right? So supervised learning. So supervised learning we have seen, right? Supervised learning or supervised machine learning, I would say. So there are two task types in this. First one was regression that we have discussed, and second one is classification. So regression is something that we have seen in our previous sessions, right? Simple linear regression, multiple linear regression, and then we have classification. So for regression, we have already seen that it predicts continuous value. And classification, it basically predicts a category or a class, right? So today we will be discussing on classification. So classification is basically a task type like regression, which is used to predict a category or class label from given inputs. So the prediction happens using different algorithms and procedure. Basically, the algorithms, we can say them as some procedure or methods where machine learns input and output. And these algorithms are known as classification algorithms. So first of all, let's discuss about type of classification. So types of classification, again, we can divide these types uh, based on the decision boundary. Okay, let me write down. based on decision boundaries, and second is based on output labels. What are output labels and what are the real world implication? I'll just come to it in some time. So based on the first one was based on the decision boundaries. So based on the decision boundaries, like regression, classification is also divided into two categories. First one is linear classification, second one is non-linear classification, right? So non-linear classification, okay, before that classification, let's take a very crude example. Let's say we have an email. So we have set of emails, email 1, email 2, email 3, and so on. Now, if I talk about the classification, I will consider these emails as my data set, and then I will, categorize these email in either of the two categories. First one, let's say, is spam email, and second category is non-spam. So you can see here, right? We are predicting the category. The category here in this case is spam or non-spam. Whereas in regression, we were predicting some number, right? When we were the advertisement example we have seen, right? Where we were, predicting the amount of advertisement that we have to spend, or if let's say we will be predicting the house pricing, so there we would be predicting house prices, right? So that house price and all those things that we were predicting in case of regression was a continuous number or a numerical value, right? But in classification, it is the category. So the category is basically spam and non-spam. So this is a very, basic example of classification problem. So whenever we divide the data set, whenever we will be able to separate the data by a straight line or hyperplane, then it is a linear classification problem. So how do we do that? So once we'll draw the plots, then you'll be able to understand that. But for now, for linear, you can just understand that data can be separated using a straight line or a plane or a hyperplane. And the algorithms that falls under linear category are logistic regression, linear state vector support vector machine, and perceptron model. So perceptron model is basically a very, I would say, the building block of neural networks. So once we'll be discussing on neural networks and deep learning, so I'll discuss perceptron model that time. Now talking about the non-linear models or non-linear algorithms. So here data is separated by a arbitrary or a random complex or a curved shape. So the algorithms that fall under this category are random forest classifier, then decision tree classifiers, KNN, K nearest neighbor we call that, and then neural networks. So this is the category or the types of classification when we, when we categorize classification based on the decision boundaries. Now, second classification is based on the output labels. So output label means what the model is predicting, right? So first one is binary classification. Second is multi-class classification. Third one is multi-level classification. And we call this as hierarchical classification also. And the last one is multi-label classification. Okay, so binary classification means whenever the output falls under binary category 0, 1, true, false, spam, non-spam, right? So that particular type of classification is known as binary classification. Multi-class uh, classification is, so here in binary classification, output belongs to either of the two classes, right? There are two classes. Multi-class classification, in multi-class classification, output is more than two classes. So I can say n classes. One second, my mouse got disconnected. Give me some time. Okay. Okay, so in multi-class classification, the output can belong to any of the n classes. So we have n classes in which our output can belong. In binary, we have two classes. In multi-class, we have n classes. So example of multi-class classification is handwritten digit recognition. So where you are writing down the number from 0 to 9 and it can recognize from, it can recognize that number from 0 to 9. And let's say if we want to predict the weather, so weather can be sunny, rainy, or cloudy. So we are defining three classes here: sunny, rainy, and cloudy. So in multi-class classification, the output label can belong to n classes or more than two classes. For two classes, it is known as binary classification. For more than two classes, it is multi-class classification. Now, talking about multi-level classification. So multi-level classification means the output labels are organized in a tree or in a hierarchy. So here classes are not flat; they follow parent-child relationship. So if a sample is classified as a Labrador, let's take an example. So it must also be classified as a dog, mammal, or animal, right? So whenever we are classifying any output which may belong to, which can have some parent classes also, then it is known as multi-level classification. Last one is multi-label classification. So multi-label classification means a multiple labels can be assigned to a simple or to a single sample basically. So a single photo might be of a dog outdoor having the sunny environment, sunny weather. So all these example falls under multi-label classification. So we will be taking one basic Python flow for each of these classification problem and then see how it works. Okay. Now logistic regression, right? So logistic regression, as I said, logistic regression is the simplest, I would say, linear classification model. So it basically comes from it. It is an extension. It uses linear equation. So linear equation. What was our linear equation that we have used in past? It was I, which is known as intercept, then C1 x1 plus C2 x2, and then so on, right? Till Cn xn. So here the output can be any continuous number. Now let's say if we want to squash this output within some limit, let's say between 0 and 1. So what we will do, we will use sigmoid function. Sigmoid function. So sigmoid function is represented by this symbol, and let's say this is sigmoid function of y. So how we will define it? It will be defined as 1 upon 1 plus e exponential e to the power minus y. So here this y, this will fall. I mean, you can replace the value of y in the sigmoid equation. So this is how uh, the logistic regression comes into picture. Now, what is the, I mean, what is basically the usage of the sigmoid function? So here, if we'll consider this particular equation, so here y, I mean, the output label can be between minus infinity to infinity, right? There is no limit of value and the value can be anything, correct? But as soon as we are using sigmoid function, so sigmoid function, what does it do? It squashes the output between just 0 and 1. Because if you'll see the graph of sigmoid function, so the graph of sigmoid function basically, let's say this is x-axis, this is y-axis. So the graph basically looks like something like this, sigmoid function. And यहाँ पे wherever it crosses y-axis, it is no, it is this value is 0.5, and this is 1, and this is 0. So if you can see, and this is y-axis, this is x-axis. So you can see here that the output is basically, it will be between 0 and 1 only, nothing outside it, right? Hence, 0 and 1, when we are limiting our output between 0 and 1, that means we are basically implementing the probability, right? Because probability of anything falls between 0 and 1, right? Nothing less than that, nothing more than that. So that is why logistic regression, I mean, the logistic regression when we are using, so it basically works on probability, and sigmoid function squashes any real number into range of 0 to 1, giving us a probability. Hence, it can be used for binary, um, I would say binary classification problems, or any classification problem which we want to basically work upon. Okay, cool. So this was the quick uh, overview of about the logistic regression. So logistic regression word में there is regression in it, but actually it is a classification algorithm, right? Just remember that. Regression word came from the fact that we are using the linear regression equation and then using that in the sigmoid function to come up with the output that limits between 0 and 1. So this is about logistic regression. Then we have more algorithms, support vector machine, decision trees. So we don't have to go deep down as part of this course in all these algorithms. Let's take the example of binary classification. And let's see how we basically use the binary classification problem. Okay. So let me go to PyCharm. We create a file, binary classification.py, and in binary classification.py, let's uh, okay, I have used one data set. Let me see if I can find that. So that was this data set of 500 customers. So let me see if I can find that. ओके, ठीक है. So this is the churn data. Okay, how, what is it? Let me explain. So this is the customer. So this is a CSV file. Okay. So CSV file contains four columns: customer ID, recency, frequency, average spent, and churned. What does it means? What does it mean? Let me explain you. So customer ID is a number, right? It can be anything. So that's not of our concern as of now. Recency means number of days since last purchase. So for this particular customer, if we'll take the example of this customer, so for this customer last purchased 52 days back. 52 days back was his last purchase. ठीक है. Then recency means number of purchases. Recency means recency we have discussed, right? Yeah. So recency means since last, I mean, number of days since his last purchase. Second, next one is frequency. So frequency means number of purchases, number of time he came and purchased, right? Number of times he came or he purchased, I would say. So 12 means he has purchased 12 times. 52 means the last purchase was 52 days back. And then average spend is basically the average spending that he do. So 429 rupees or dollar, you can consider anything. It is the average spending that this person basically spends. And then churned means 0 and 1. Churn means whether this customer will be returning or whether this customer will not be returning, means lost customer, or this customer will return in future, or basically to come and purchase again. For example, let's say if I'm buying from Amazon, and then based on my shopping behavior, which can be recency, frequency, average spend, Amazon can predict whether Abhinav will return back and purchase something else from Amazon in future, or whether he will not purchase. So this is the basic, I would say, classical binary classification problem, customer churn prediction. So how do we implement it? Let's see that. So this is the data that we are going to use. And let's see how we are going to build a model to basically predict whether the customer is churning or not churning. So we'll be writing the steps first of all, right? So what will be the steps? Okay, so our basic steps will be importing necessary Python imports. So I'm just building a code map as of now, right? Then first step, first real step will be reading from the CSV file. Read the CSV file, data from CSV file. Then next step will be define features and labels, right? We have to define features and labels. And then we have to do train and test split of the data. Train, test, split. After that, I have to define my model, define the model. Once I'll define the model, what I'll do the prediction. So make the prediction. and then predict for new user data or new user input. Okay, so this is our code map for the basic flow. Any doubt in this? Why we are doing that? So these are the steps I have mentioned that we are going to follow in order to implement the basic classification. Any doubt? Okay, let me copy these into the binary classification.py file. So, okay, imports we will do later on. First step is to read from CSV file. So CSV file will be reading from pandas, right? So okay, so first import that we have to do is import pandas as PD. First step. Okay, so df equal to pd dot read CSV is the method which we will be using, and the path of the CSV file is data. It is under data directory, right? It is under data directory, and this is the name of the file. So let me copy this name. Okay. So this will be going to, it will be going to read the data from this CSV file, and it is creating a data frame df. Okay. Next step is to define features and labels. So just look onto this file. What features we can define here? Will customer ID matters to us? No, right? It will not matter. It can be anything, right? This is just for the reference 1, 2, 3, 4, or any number 100, 200. It is not of, not of that importance for us when we will be doing the prediction or when we will be building the models. Features that are important for us will be recency, frequency, and average spend, right? So we will be defining these as our feature, and churned this particular column as our label. Label means the output, right? So this will be our label that we are going to define. So let's go back to the code. So let's define the features. So features are defined as two-dimensional. So I'll be defining like this df, and what is the first feature that I'm defining? It is recency. Just make sure the spelling that is there in the data set and what you are defining here should be matching. Then this will be frequency, second one. Third one will be average spend. Average spend. Okay. So this we have defined our feature. Next step is defining the labels. So what is the label? Name of the label churned. CHURNED. Okay. So we have defined our features and labels. Next is doing the train test split. Okay. So train test split when we will do, so how we will do that? So X train, comma, X test. So this is feature train and test split. Then we'll be doing label, I mean output train and test also. So Y train, comma, Y test. Then we'll be using train test split method. Train test split from sklearn model selection, right? If I will select this, it has imported. And random state This can be anything, but we usually give 42, so we'll be using 42. So this we have done. Train test split is something that we define, that we do basically using train test split method. Okay. Now next step is define the model. So this model for binary classification, we want to use logistic model, logistic regression model. So I will define model equal to logistic regression. I will define, and then I will fit the data, train data, right? Train data is basically feature and label data. So X train and Y train is something which I am giving to this model and telling boss, you have to train, you have to basically study this particular data. What data? Only train data we are giving this model to study. Okay. Then next is the prediction, making the prediction. So making prediction, we basically, let's say we define by pred. So prediction we will do on the, we will do basically on the test data. So what we are doing here, this data, we have 500 set of data. So 80% of the data, we are using it to train this particular data set. And then remaining 20% of the data is the test data, right? So train data is something on which model is trained, and test data is something on which model will do prediction. But when we are not implementing the complete ML pipeline, so we might not be using the uh, this prediction on the test data. But for now, let us write this and let's do the prediction on the new user data. So when this will be useful? So this will be useful when we will be evaluating the model performance. But for now, we are not evaluating the model performance. We are just learning about the basic workflow of the binary classification. So as I said, right, once I'll complete all the basic workflows of regression and classification, I'll take one example of either regression or classification and build a complete ML pipeline. So in that particular case, this particular thing, this particular prediction that we are doing on test data, that will be, used in that particular case when I'll do the prediction. I mean, when I'll be building the whole ML pipeline. Okay. So predict for new user data or input. Let's say we'll give some example input. Let's say new data I'm giving. And new data, I'll just convert into the data frame here itself. So pd dot data frame. And I'll give input as a dictionary, right? So dictionary may I have to define the key value pair into key value pair. So recency, let's say I want to give recency as 40. Frequency as 30. 30 is more, let's say 8. Average spend is, let's say 550. Okay. So this is the new data that I have. I want to predict my outputs. What is happening here? So I had a data set, right? So using this data set, I have trained my model, right? My model is ready. I have trained my model and it understood the patterns in this data and now it is ready. So once it is ready, once the model is ready. So it is ready to predict on the new data, right? It is ready to predict on new data. So we are looking onto this part, right? So we are considering that model is ready. But generally, as I said, I'm repeating again. So model is ready. This we decide once we evaluate the model using the performance evaluation metrics. Again, I'm repeating. So this I'll be covering at last. But for now, let's consider that model is ready. And once the model is ready, it is ready to predict on new data, and that's what we want to see. So this data is basically the new data on which we want to do the prediction. Okay, any doubt? I hope not. Sarthak, all clear? Devansh,
Yes, yes.
Deepansh, okay. ठीक है, so this is the data that we want to predict our output. So, mm, okay, now what we will do, we will basically uh, do the churn prediction. So let's say churn pred equal to model dot predict new data, and new data again. So this data has to go, this basically go as a list. So we will be considering this as the zeroth element. So here what we will be doing, model dot predict we are writing, and we want to predict on new data. And the first we have to consider as the element on first index. And this is a list. Okay. Now, let's print this. What does it print? Okay. Let me run this. And here, let me write churn pred equal to churn pred. If I'm running this, okay, this is okay. It is running, still running. I don't know why it is taking this much time. Okay, let's put some print statement first. Okay. Import cluster. I'm writing some of the print statements. Let me try to run this again. Okay. So it is okay. It is printing churn prediction as 1. So the prediction will be 1 or 0, right? So 1 means this will, this customer will be churned. Churned means it will basically go away or it will not return back. Okay. And recency go, let's say recency, if I'm giving 1, frequency I'm giving more, uh, 80 if I'm giving. Let's see what does it do in this case. Okay, it may be it is giving churn prediction as 1. Hmm. Which should not be the case because, okay, average spend if I'll increase. Okay, so churn prediction. Okay, let's see. I mean, let's see how we can improve it. So churn prediction is basically just giving the value 0 and 1. Let's try to print the probabilities also, right? So churn probabilities. So model dot predict proba new data, and this has to be in 2D matrix. So 0 throw ka first, and let's print this probability also. If I run this, okay. So churn probability is 0.99. 0.99. Okay, पहले तो before any confusion, what is the meaning of churn? Let's see. So churn mean loss or turnover. That what I was basically telling you, right? Whether customer or employee, or I mean customer in this case, whether he will leave or stop purchasing the item, right? So churn probability means 99 point, this 0.99 means that this is the possibility of 99 percent possibility of this customer going churn, and hence the churn prediction is coming as 1. Let's try to analyze this data. Okay, 0 0 0 316 819 316. Okay, 59% probability. Again, it is giving churn prediction as 1. Okay, we might not be doing something correct. Okay. Hmm. Okay. Okay. यहाँ पे let's write some logic. Print f. Okay, it is giving churn probability. Prediction, it is always giving 1. Okay. F string I'm writing. Predicted class churn if churn prediction equal to 1, else not churned. इसमें churned ही आएगा, right? It is giving churned. Mm. Okay, cool. So why it is happening is because this data, in this particular data, the data that what we are giving here, now it is mostly resembling the data where it is where the value of the churned is 1 here. Now, how we can improve this is that instead of using this churn prediction, na, what we can do based on we can play on the probabilities. So, for example, when I'm running this program, it is giving probability as 0.59, right? Now, what we can do is basically we can create a logic if churn probability is greater than zero point 0.5, that means 50% chance is there that this customer will not return, right? So in that case, we can print churned, else we can print not churned, right? So so this particular logic that I'm writing, this can be a custom logic that we can basically define, right? So what we are doing in this particular model is that we are basically finding out the probability. Now, if you remember in one of the data, 0.99 was the probability that was coming as churn, and it was giving churned on. I mean, the output of the model was coming as churn, right? Again, the logic that we basically write, so this 0.5, so basically this particular thing, churn prediction, this also works on this particular logic that it basically internally uses this logic to define whether the customer is churned and not churned. So whatever data that we are using, mostly, I mean, most of the data that we have used, it is basically coming as churned. So how it is working internally, for that, I'm just writing down this logic. So here it is coming churned every time. I'm not able to collect any data where I can basically uh, use it as a non-churned data. Let me try out few more. 93, 16, 593, 93, 593. I'm not able to get the data where I can show you that the customer is not churned, will not churn. 60% probability इसमें भी आ रहा है. 24, 16, 545. Hmm. Okay, that means, see, that's where I was talking about underfitting and overfitting, right? So right now, so we have just considered that model is our model is, it's a well fit model. But when we will basically work on finding the performance evaluation metrics and then evaluating this model, so this model will may not evaluate to a good model, right? Because I have used the data of 0 also and 1 also, but every time it is giving the output as churn. So there is something for sure that we have to fix in this model. But the main intention for showing this particular problem is to show you how do we train the model using the classification, binary classification, and how the prediction happens for the new data, right? So that's where this machine learning model building becomes a little bit complex because you have to consider the performance evaluation metrics also. So this is a classical example you can see. So for every data that I'm giving, it is showing me the output as churned, right? Even if in the initial data set, I have taken both examples, right? Churned and non-churned wala data. So there is something for sure that we need to fix in this model. But as part of this particular demonstration, it's not our purpose. So our purpose is to just see how do we train our model for the classification, binary classification problem. So this is about binary classification problem. And as I said, right, so once I'll cover all the examples of classification, I'll build a complete ML pipeline where we will evaluate the model And for these kind of situation where I mean for every output, for every input that we are giving, it is just showing us one output. We will see how do we fix that particular problem. So it is like either improving the data set, number of data customers, I mean this number of samples in that feature, or do we need to reduce the samples from this particular data set, or do we need to increase the samples from this data set, or do we need to include any more meaningful features? So everything falls under the model evaluation process. So this is about binary classification. So next, what we will see will be the multi-class classification flow. So we'll take a 10-minute break here, and then once we'll reconnect, we'll see how do we do multi-class classification. So let me start 10-minute timer, and let's meet after 10 minutes. So we'll be going to see the multi-class classification problem now. Okay, before that, so we basically sklearn uh, basically provides the sample data set that we can try out, right? So first of all, let's Google sklearn uh, sample data sets available. So if you'll go to skykitlearn.org and if you'll look onto data sets, so it has a lot of data sets available which you can use in your Python code when you are learning machine learning, and if you are building any sample models for your understanding. So iris plant data set, diabetes data set. So there are, I mean, these toy data sets means the total samples or total rows will be not that big rows or not that many rows. And then real world data set also it provides. So there are a lot of data sets. So you can probably, go to this site and try to explore on your own. So for multi-class classification, we will be using iris plant dataset. So iris plant dataset, okay, what does it say basically? So it is basically smaller data set where it has provided the sepal width, length, petal length and width. Okay, what are sepal and petal? So petal you know, right? Sepal and petal. So it is about flowers. So flowers में sepal and petals are there. So let's say agar if this is a flower, any flower, these are the petals. Petals means pattiyan, right? And sepals are basically the greener part. So these are basically sepals and the colorful petals are the petals. So यहाँ पे these are the petals, right? ये हो गई petals and these are sepals. Now, what this data set says, it is basically uh, giving it is containing the data for these petal length. So this is petal length and petal width. Okay, so this is petal width, L and W. And then it has the data of sepal length and sepal width also. So one row contains petal length, petal width, sepal length, sepal width, and based on some particular uh, pattern, there are three kinds of flowers that they have defined in their data set. Let's see that. So see, they have defined the sepal length, sepal width, sepal petal length, and petal width, and then these are some of the samples there. And then finally, based on the sepal length and sepal, I mean, basically on this data, they are defining that particular row in either of these three classes. So this is flower one, Iris setosa, Iris versicolor, and Iris virginica. So these are three flowers. And the output can belong to output, possible output, I would say. Possible output can fall in more than two classes, right? So whenever it falls under more than two classes, it becomes the case of multi-class classification, right? When it was exactly two, it was binary classification, right? So here the possible output can belong to any of these three classes. So यहाँ पे three classes है. output will still be one only, either iris setosa, iris versicolor, or iris virginia. So this is a classical problem of multi-class classification. So what we will be going to do in our Python code, we will be taking the sample data set of this iris plant data set that scikit-learn community has provided. So let's see that how do we do that. Okay, so let me create one more Python class. Okay, multi-class classification. Okay, so multi-class classification maybe, so I'll just copy these steps, these code map. I have copied that code map. So read that CSV file की जगह, I would say load the data. Hmm? Load the required data. Okay. Now, how do we do that? So when we want to load uh, the data, what we will do is that there is one load iris method is there, which we have to call in order to load this data. So all these three plants, if you can see, sorry, all these three flowers, if you can see, belongs to iris, category. So that is why this is known as iris dataset. Iris dataset. Iris dataset. Okay, let me write down directly. So let me define a variable iris equal to, see, dataset load iris, it is coming, and I have to select this sklearn.datasets. So from sklearn, I have imported datasets, and from datasets, I have loaded the iris dataset. So iris dataset basically contains the data of flowers where sepal length, sepal width, petal width is given, and then the output is output is provided there, right? And let's say if I'll print this, print iris, let's see what happens before we move further. See, it has printed the data set that is it has downloaded from their website. So this is basically sepal length, sepal width, and then petal length, petal width. And species, I don't know why they haven't provided the species. Uh, okay, target. Okay, so they have given. Okay, it has not provided the. Okay, so this is the final output or the final multi-class that 0, hmm, 0, 0, 0, 1, 2. So 0, it is telling it for Setosa, 1 for versicolor, and 0, 1, 2 for Virginia. So they have printed down their samples, and then output they have finally, I mean, the labels, target labels, you can see here target, right? They have defined it separately. So for the first column that you can see above, right? So this was the output, which is 0, means Setosa. So ये पहले वाला जो है ना, whatever the first data is there, this one, the flower is Setosa for this. For second one, it is again 0. I mean, that's how they have defined this data set. Okay. For second also it is Setosa, and for last it is 2. So this one is the last data set. So for this sepal length, sepal width, petal width, the target or the flower for this particular data set is Virginia. Okay. So we have loaded this data set, and now let's define the features and labels. Okay. So let's define the features first. So x equal to pd dot data frame, and then iris का data, iris dot data, columns equal to iris feature names. Okay. Print dot data. Okay. So this whole data is divided into two part, data and feature. So यहाँ पे we are creating the feature. So for that feature we are giving reference as the data, and then from that data we are defining the feature names, basically whatever feature name is provided in this data. Okay. Then y equal to pd dot series and iris dot target. Right. Let me print the this data, iris data again. You can see here, यहाँ पे they have defined data, right? So data is the key, first key, and the value is array, right? So when we are defining the feature, we have told this particular this data frame, we have defined this particular data frame that you have to look into iris.data, and then iris.features. I mean the columns, whatever are there, iris.features. Where is the column? See, this is the feature name. This is the feature name that has been defined. Sepal length, sepal width, petal length, and petal width. So that's what we are telling, that consider iris.data and columns will be iris.feature name, whatever is there defined in that. So sepal length, sepal width, petal length, and petal width becomes our feature when we run this or when we write this particular line. Now for defining the labels, we have told that y equal to pd dot series, and then in that series iris dot target. Keep whatever is there in the target. So this is the target, right? So this is the target, and target has target names. So our target name, if I'll print here, target classes are iris dot target name. If I'll run this, it will give me the target classes. So my target classes will be Setosa, Versicolor, Virginia, which are three numbers. So hence this is a case of multi-class classification. Okay. Next step is to do the train test split. Okay, so for train test split, we will write our usual command, right? X train, comma, X test, comma, Y train, comma, Y test. And then we will be using train test split method. And again, we will do this simple train test split. Now we will be defining the model. So these are, common steps, right? Model equal to logistic regression model I am defining. And here I'll do model.fit and making the prediction. Again, this is not required in this current context, but let's write down y pred equal to model that predict on the test data set, then predict on the new user data. So let's define a new data for any random flower from the iris family. let's say sample I am giving, sample equal to I am giving 5.5 comma 3.7. So these are sepal length and sepal width in centimeters, and then petal length and petal width. So this is a random flower sepal and petal dimensions I have given as a new input. Now I'll convert this input into data frame first step, right? So pd dot data frame, columns में I will write down as x dot columns. What does x dot columns means? So यहाँ पे जो हमने x define किया था, whatever column I have defined here when I was defining feature, define the same column here. So यहाँ पे columns में I will write down x dot columns. Okay. So this is about the sample data frame from the input. And then predicted class, predicted class I will do using model dot predict and sample df. And again, this has to be the first index. So 0th index I will give. And then the, let's try to run this first. Print, what is the predicted class? Should be coming between 0, 1 and 2. Okay. 4 columns pass, data has 5 columns. Where okay, sample df equal to pd past data had 5 columns. I have to pass only 4 columns because fifth column is something we will be predicting, right? df dot. Okay, let's fix this using ChatGPT. Let's see what it says. This is my code, and I am getting this error. Fix and explain. Arey yaar, okay. Instead of 1.5, I have given 1 comma 5. Okay, got it. Okay, now let's run it. Output is 0. So 0 belongs to Setosa, right? The output can be either 0, 1 and 2. Now, if we want to convert this into the actual class, how we will do that? So predicted class can be either 0, 1 and 2. Let me show you again why 0 is Setosa. So when I'm printing the data set, here you can see, right? This is an array, right? And array has 3 length. I mean, this is a list. The index first, index 0 belongs to Setosa. Index 1 belongs to versicolor. Index 2 belongs to Virginica. And for the predicted, the output, the output that I'm getting, it is showing as 0, which is setosa. Okay. Now setosa is there. So instead of 0, 1, 2, I have to basically print the actual predicted class. So for that, what I will do, I will write down a print f string predicted class is equal to predicted class उसके लिए iris dot target names, and target names, see, this is the target name, right? Target names is the key, and then the value is the array or a list. So I'll just, in this particular key, I will just pass on this particular value index. So यहाँ पे I'll just pass the predicted class which is coming, right? So predicted class, if I'll run it, it should show me setosa now. Predicted class is setosa. That means that the new data that I am giving here, so this is the sepal length, sepal width, and petal length and petal width, which I am giving for a new data for a new flower. My model will be able to predict which flower dimension is the new data coming. For the new data, which is the predicted flower, which my model can predict as per the dimensions given. So here in this case, it is setosa. So this is the example of multi-class classification. So multi-class classification means my output can fall in any of the multiple classes. That can be more than two. Exactly two classes, when we exactly had two classes, it is the example of binary classification. When we have more than two classes, it is the example of multi-class classification. But anyhow, the output will still have one value out of these three values, right? Even in binary classification also, the output was just having one value out of those two value. So binary classification में either 0 or 1 होता था. Still the output will be one value. And here in multi-class also, we have multi-classes like Setosa, versicolor, and Virginica. Although there are multi-classes, but the output is just one out of these multi-classes. So this is about multi-class classification. Now multi-label classification में क्या होता है कि output can be of many category, something like Setosa, versicolor, Virginica. Sorry, the classification, the output class can be more than two, but output can belong to any of these categories. Either it can belong to either just Setosa or Setosa and versicolor or Setosa or Virginica. That's where the term multi-label classification comes. So next thing that we are going to see is multi-label. Multi-label classification. Multi-label, label means output. Label means output, right? So output can belong to multi values, or output can have multiple values. Multiple values it can have. Okay. So next thing is multi-label classification we will see. But any doubt in this multi-class classification? See, the code map for the basic flow is always same, right? We are doing necessary import, we are reading the data, loading the data, or reading the CSV file. Whatever is the applicable case, then we are defining features and labels. Then we are doing train and test split. Then we are defining model, and then making the prediction, and then predicting on the new user data or new input, right? This is a common code map for basic flow. Any doubt before I can move further? See, as long as you are, understanding the code well and fine, you'll be able to recall till tomorrow. But if you'll not practice on yourself, after 1 or 2 days, it will be completely wiped off from your brain. So I would recommend you to practice once from your own, and start from building the code map, and then copy that code map into your Python file, and then one by one, step by step, implement that Python code, and then see what is happening on the under the hood, what exactly is happening. And before moving, before picking up any problem, just define what is your goal, what do you want to do. Because in machine learning problems, when complex topic comes, or when students are learning these concepts, sometimes they will be able to do the coding, but then they fail to realize exactly what needs to be done. So just before you pick up any problem, just clarify the end objective or the goal that you want to achieve. Okay. Okay. So moving on to the multi-class classification, sorry, multi-label classification. Now, multi-label classification may, what uh, example I am going to take, I'll just give you a brief overview about it. Let's say there is a song, and song can belong to rock category, pop category, jazz category. Okay. इसको मान लो, let's say this is song 1, this is song 2, song 3, and so on. So song 1 basically belongs to rock category, and it is belonging to jazz category also. Song 2, let's say, belongs to rock category and not pop category or jazz category. And song 3, let's say, belongs to rock category and pop category, but not jazz category. So if you'll closely look, the output basically can have more than one label, right? For this particular sample, the output labels are rock and jazz, right? For the second sample, the output label is just rock. And for song 3, the output label is rock and pop. So here output belongs to more than one label. That is why the term multi-label comes into the picture. So this is multi-label classification problem. Multi-label classification. So this is what we are going to implement. Okay. So let me create one more Python file. Let me name it as multi-label classification. Let me copy paste this code map. Read the CSV की जगह, let's say create, I'll create sample data set in this case. Create sample data set. Okay, so let's create a sample data set. So data I'll create, and I will define column as tempo, right? You know tempo of the song, right? So tempo, let's say if I'm defining the tempo of my data sets as 120, for song 1 it is 120, for song 2 it is 130, then 110, 140, 100, and 140, let's say, huh? Then I will be having danceability. Danceability. So danceability is a parameter which will basically let you know how much possibility a person can dance on that particular song. For example, it is if 0.8, so 80% chance is there that for this song, 80% of the people who will hear, they will feel like dancing. Then for second song, it is like 60%, so zero point 0.6, zero point 0.9, very high probability that for third song, people will, 90% of people who will, hear that song will feel like dancing. Then zero point 0.5, and then 0.6 or 0.7. So this is about danceability. Now, next column that I want to define is rock. So first song basically belongs to rock category. Yes, it is belonging to rock category. Second does not belong to rock category. Third belongs to rock category. Fourth does not belong, and fifth belong. Then second category, pop. So first song belongs to pop category. No, it does not belong to pop category. Second belongs to pop category. Third also, let's say, belongs. Fourth and five do not belong. Then last one is jazz category. So jazz category, first song belongs to jazz category, second belongs to jazz, third belongs to jazz, third, fourth belongs to jazz, and fifth do not belong to jazz. So this is the sample data set that I have provided. So I have given the tempo, danceability, then these are the multi-label labels, basically rock, pop, and jazz. Now let's, okay, before moving forward, we will convert this data into data frame, because this data that I have defined for now, it is just what it is right now. It is just a sample dictionary, right? So I'll create a data frame. How I'll create data frame? pd.data frame, and यहाँ पे ओके इसमें I'll just pass data frame. ठीक है, I have converted it into data frame. Now next step is defining feature and labels. Let's define feature first. First feature is df. Okay, first feature is tempo. Tempo is the first feature. Second feature is danceability. Just these features. Okay, so I have defined my features. Next one is labels. So I have multiple labels, right? So in this case, I will define all the labels: rock, pop, and jazz. Okay, so this is about my labels. Now let's do, so you might be seeing here, right? So initially, though, in all those other problems, we were defining just one label, right? Yeah, maybe only one label was there. Binary classification, maybe only can't define yet. Okay, this is just the one label we are defining, but this is the example of multi-label classification. Multi-label means multiple labels, so that is why we have defined multiple labels here. Now, next step is to do train and test splits. Again, same routine step: X train, X test, and then Y train, Y test equal to train test split. Uh, Train test split. And okay, same thing we are doing. Test size 0.2, matlab out of all these data, 80% will be used for training the data, 20% will be used as a test data set. Random state 42, this is randomly we can give any number. Why it is asking to rename this? X declared, redeclared, Y train defined above without usage. Okay, what is Y train, Y test? Nothing. Should not bother, right? अच्छा, ये यहाँ पे कुछ तो एक्सपोर्ट हो गया. ओके, दिस इज अ रॉन्ग एक्सपोर्ट. लाइन नंबर 5 पे लेट मी रिमूव दिस. Okay, now we are good. So this is where we have defined train test split. Next one is defining the model. Now, logistic regression we have seen, right? So logistic regression में what happens is that ये ग्राफ होता था, right? Logistic का sigmoid function where your ग्राफ जो है ऐसे जाता था, and then लाइक दिस इट यूज टू गो, यहाँ पे 0.5 होता था, दिस इज 0.5, देन मैक्सिमम वैल्यू वाज 1, this is 0, right? And this was the case of logistic regression, correct? So logistic regression. So in case of binary classification problems and multi-classification problem, we would be able to use logistic regression, right? But uh, for multi-label classification problem, we will be using decision tree classifier or a complex model or complex classifier model or non-linear classification model. So here in this case, instead of using logistic model, we'll create a tree. Tree means we will be using decision tree classifier. Decision tree classifier. यहाँ पे भी we have to give random state as some random number 42. Let's give 42. And then what we will do, we will define that, okay, we are using decision tree classifier and we are using this for multi-label classification. So something multi-CLF, let me write. And I am defining here multiple output classifier. Multi-output means a particular label can have a multiple output or a multiple values associated with it. And then I have given whatever यहाँ पे tree, whatever tree that I have made. Okay. Let me name this as model. Okay. Now this is my final model that I have built, right? Now I will do model dot fit X train and Y train. Means I'm just what you say, I'm just training my model onto training and I mean feature X train and Y train. I'm just training my model on these values. And then next step is about making prediction. So Y pred is model dot predict X test. I will do, right? This is usual steps. Now predicting on the new user or new data, basically not user data. Okay, new data, I would say new data or new input. Now here, let's say I have to take an example of a song. I will take with tempo as 125 and danceability equal to 0.65. ठीक है. How do I create this data? Let me create new song equal to directly data frame pd dot data frame, and then data frame के अंदर I'll create one dictionary का पहला key I will write down as tempo and tempo में 125 I will write. दूसरा I will create danceability and danceability में let me write down as 0.65. ठीक है. Now न्यू प्रेडिक्शन जो मैं करूंगा, न्यू प्रेडिक्शन इक्वल टू मॉडल डॉट predict new song I will be doing, and then let me print down print new prediction, whatever is the new prediction, pred new prediction. Okay. Now new prediction jab whenever I will run this program, it will what it will do basically, it will give the output in 0 1 1 format because यहाँ पे whatever data I have given, so data is something like जो ट्रेन किया था मैंने डेटा, that I am writing tempo, danceability, and then rock, pop and jazz were there, correct? So यहाँ पे there was some value 120 था, danceability let's say इसका 0.8 था, and then rock, pop, jazz was 101 in this case, right? 101. So this is the output. This is basically the label that defines basically the output, right? 101, or it basically will be defined using three numbers. 10, I mean any combination of 1 and 0, representing these three numbers, representing these three places, right? So mera output, whatever, right now when I'll run this program, so new pred will basically come as a three digit output represented by 1 and 0, which will define whether on which all category this particular songs belong to. So if I'll run this program, it has given the output as 1, 0, 0. तो 1 अपना रिप्रेजेंट करता था रॉक. So this basically belongs to rock category only, not pop and jazz. So this is the prediction. If we want to make this prediction into a readable format, how do we do that? So uh, let me write down new pred df equal to pd dot data frame, and data frame में first value, first parameter or argument which I'll provide is new pred, which is my prediction, and columns I will give as rock, pop and jazz. ठीक है. Now if I'll print new pred output, it will basically print. Okay, it has printed the final output, right? So you can see in this table, it just belongs to the new song, just belongs to rock category. Okay, let's try to change these values, and let's see if we'll be able to define, if we'll be able to see some more prediction. See, in this case, when I've changed the tempo to 300 and danceability to 0.9, my prediction is that the song belongs to rock category also, one, and pop category also. So this is the classical example of multi-label classification. Okay, we don't have time to cover the multi-level classification. Probably we can cover that in next class. But let's recap what we have learned today. Okay. So we have seen what is classification. Okay. Oh, 1 second. Sorry. Okay. So we have seen what is classification. Now, classification is divided based on the boundary and based on the output. So based on the boundary, classification is divided into linear and non-linear category, right? Linear category may we have seen some of the algorithms that are there are logistic and linear SVM and perceptron model, right? Non-linear may we have seen it. We have random forest, decision tree, random forest classifier, decision tree classifier, etc. Right? Now, based on the output, we have seen first was the binary classification, and we have seen in binary classification, we have seen the example of customer. I mean, we have taken the use case of customer churn use case, right? Whether customer will be churned or it will not be, he or she will not be churned. Second is multi-class classification. Multi-class classification, we have seen that the output can belong to more than two class, but eventually the output will be single output only. So multi binary classification may allowed or not allowed, I would say uh, classes equal to total classes were two classes here. multi-class में classes was greater than 2, and in both of these cases output will exactly belong to one of the available classes, exactly belong to one class. Let me write it down like that. ठीक है, this we have seen. Now third thing that we have seen multi-label classification. So multi-label classification में classes can be anything. It can be I would say greater than one, right? And इसमें in this case output output can belong to any number of classes, right? We have seen this particular thing. And for all these things, for all these binary classification, multi-class classification, multi-label classification, we have seen basic machine learning workflows. So when I'm talking about basic machine learning workflows, we haven't considered the model performance. We haven't considered the evaluation metrics, and we haven't considered whether our model is overfitting or underfitting. We haven't considered any of these situations. Now, tomorrow we will see the example of multi-level classification. So, level जहां भी आता है, whenever we talk about level, it is about hierarchy or parent-child relationship that comes into picture. So, multi-level classification is something which we'll be going to see in our next class. And then we will also discuss on performance evaluation metrics for classification task type. And once we'll do that, we will finally implement one complete regression workflow for we will implement the complete machine learning pipeline for regression workflow. So with that, we will complete our supervised learning. And then next, we will be checking about the unsupervised learning and basic workflows about unsupervised learning. So once I teach you how to build a complete, ML pipeline. So for all these problems that we are seeing here, right, basic workflows. So as a homework or as an assignment, try to implement the complete ML workflow from your own side, where you will be considering, uh, you know, where you will be basically defining the model, then evaluating the performance evaluation metrics, and then writing the logic to evaluate whether your model is a good fit, overfit, or underfit, and then basically fixing your model based on the final result. If it is overfit, then what steps you need to take. If it is underfit, what steps you need to take. Everything, whatever is applicable, you just implement that particular concept in every basic ML workflow that I'm showing you. But before that, I'll show you one complete ML pipeline. As I said, I'm saying this again and again because I want to show that particular complete ML pipeline once. And as an assignment, you implement those concepts in all these basic ML workflows. Because if you'll not do work, hands-on from your own side, you'll be able to remember these concepts for 1 or 2 days, and then it will be completely, washed. Vanish off from your brain, 100%. It needs a lot of practice. It needs, lot of hands-on from your side if you want to persist these concepts in your brain for longer time. So just remember to practice these concepts on your own. Do hands-on, do lots of hands-on. If any doubt is or if any confusion is there, do let me know. I'll try to explain whatever confusion or whatever doubt you have. And machine learning, okay, we'll be able to wrap up machine learning by next week, I would say, and then we will start the deep learning. And after that, we'll start the Gen AI training. Okay, any doubt or any questions before we wrap this session? Sarthak, all good?
Yeah, all good. I don't have any doubt.
Anirudh, any doubt or any suggestion, anything from your side?
Not as of now. I will go through this again and will let you know.
Yes, yes, you have to do hands-on. I'm telling you again and again. If you will leave it at this stage, you'll not be able to, repick this topic in immediate future. But if you'll do practice, immediately for next couple of days, 100% you'll be able to overcome. Uh, I
Yeah,
mean, 100% you'll be able to understand these concepts.
sure,
Cool.
sure.
I think that's pretty much it for today then. Let's meet tomorrow and we'll discuss multi-level classification and then performance evaluation metrics for classification task type. Okay. Thank you, everyone. Have a nice day ahead.